A very good day, my dear postgraduate students. The topic for the day is Warburg effect. This must be Greek and Latin to you as well as me. Frankly, this does not belong to our subject, but it is a university question for us. Let us see what it has got in store. And this gentleman, incidentally, is Otto Heinrich Warburg, who has been awarded the Nobel Prize. More of an author of chemistry rather than pathology. We all know that the mitochondria are the powerhouses of the cell. The cancer cells do not utilize mitochondria in the same way as the normal cell. The normal cells utilize them in one way, whereas the cancer cells in another. And that is the basic principle of the Warburg effect. Normally, during mitochondrial respiration, there is the production of the reactive oxygen species, which can lead to the lethality of the cells gradually. Also, there is a production of the oxygen and the hydrogen peroxide, which can result in cell death. The Warburg effect came into force more than 1 century back. Otto Warburg identified that tumors consume less of glucose. Then where does the energy come from? The glucose fermented by lactate by aerobic glycolysis, even when the oxygen is abundant, is the basic principle. So they do not utilize the oxygen as such, but then there is a method of glycolysis by which they are procuring their energy. The aerobic glycolysis is seen in the cancer cells, and that is called as the Warburg effect. In fact, they say that this is a part of a metabolic reprogramming. Too complex, but let us leave it at that. And what is on my right? The Memorial Sloan Kettering Cancer Center. So this is one. You find that a lot of research obviously would have been done on this. That is why a person is the possessor of a Nobel Prize. This is an important flow diagram which will be repeated again and again. So what happens is there is a well-differentiated normal tissue. So with oxygen, there is a production of glucose, pyruvate, then oxidative phosphorylation, and 36 molecules. A lot of energy of ATP is being produced. Without glucose, the same differentiated or normal tissue will lead to the production of glucose, pyruvate, and then there is an anaerobic glycolysis. And only about 2 molecules of ATP are being produced. So this is the story. In this case, I am having only 2 molecules of ATP. Now, let us go over to the other side. It is a proliferative tissue or tumor. And irrespective of the oxygen status, there is a production of glucose and pyruvate. So far, the story is the same. But then 5% of the pyruvate goes in for oxidative phosphorylation. That is a normal pathway. Whereas 85% goes in for aerobic glycolysis. Not anaerobic, it is aerobic glycolysis. And so you find that 2 molecules of ATP, Warburg effect, are being produced. So you find that 85% without the direct glucose is able to produce the Warburg effect. There is an increased glucose consumption, important for the biosynthesis precursors for anaerobic reactions. So the pathways that include and produce lipids, nucleosides, and proteins. This is another one, we shall come to it. So there is a proliferating cell which require ATP. Look at this one. This is a normal proliferating cell. There is a ATP. Look at the quantum of ATP. This is more in this case. Lower down, it becomes an abnormal thing. It gets tapered off also. So there is a normal oxidative metabolism that we had been mentioning. There is an increased glucose consumption for the biosynthesis of the various precursors. However, after this lactic acid fermentation, what happens is here In this case, the ATP is minimal, and then there is a greater demand also, and NADH is being converted to NAD. Pyruvate is being converted to lactate. There is a fermentation. So this is one. It is for this finding that he has been awarded the Nobel Prize. Also, there is a process called as anoikis. Many of the reference articles that I had gone through have mentioned this anoikis. What happens is there is actually the tumor cell, it is able to lay down its own basement membrane and then it is able to grow on it. That is the thing. But in anoikis, what happens is there is a resistance, and then you find that in spite of it, that is able to survive. In spite of this resistance, it is able to survive. So again, the same old story, well-differentiated tissue. Now you will be better authors than me. There is abundant glucose, pyruvate, little amount of lactate conversion. So there is a mitochondrial activation, and you find that there is a glucose. ATP is being produced. Here the oxygen is less. Glucose is being produced, pyruvate and lactate. There is a fermentation, anaerobic glycolysis. Only about 2 ml of ATP is there. So this is one. But whereas in a case of a tumor, you find that because of the pyruvate, abundant 85% is being converted to lactate. And as a result of which, you find that the tumor cells are able to produce more of the ATP which is required for their growth. The paradox of cancer's Warburg effect, cancer and glucose metabolism. This is a superb reference article. The same thing all over again. Always repetition is the mother of knowledge. So this is the aerobic and this is the anaerobic that is over here. So what happens is there is a biosynthesis, there is a proliferation that ultimately takes place. When reactive oxygen species are there, normally you find that there can be a DNA repair as well as the prevention of metastasis, which is not there in this case. So in a cancer cell, there is the proliferation as well as the metastasis. There is a TCA over here, tricarboxylic citric acid cycle. All of us would have read past biochemistry and forgotten. It increases the glycolytic metabolism and pyruvate formation. Kindly memorize this particular one. Lactate fermentation takes place, diverted away from mitochondrial metabolism, and this is called the Warburg effect. R.A.T.S effect is being avoided, and metastasis is being increased. When there is R.A.T.S, it prevents the metastasis. When it is being avoided, there is metastasis. Warburg effect on the cancer-associated fibroblasts. Normally, you find that there is a basement membrane, there is a fibrous tissue, there is a in situ lesion, and there is no malignancy. But what happens over here is there is an intact basement membrane, maybe peripheral rim of myofibroblast, and then the epithelium. But then there is a proliferation, there is a DCIS, ductal carcinoma incident. But in this case, you find that there is a breach in the basement membrane, there is an invasion, and there is a promotion of the growth as well as the metastasis. This is the effect of it in the Warburg effect. So the same thing is given over here in a normal cell. These are all the changes that take place. Whereas in a cancer cell, you find that pyruvate is getting converted to lactate, and then a lot of this ATP is being produced on its own, and it acts on, this is the mitochondria, it acts on the electronic transport chain proteins. So it is able to derive its own energy and grow out of it. So strangely, I found that the Warburg effect is not limited to pathology but in diagnostics also, and it rather forms the basis of the PET scan. So in this case, it is really normal, whereas here there is a widespread metastasis called the FTG PET scan, a case of malignant melanoma. So thanks to this bioxan picture, again, the role of Warburg effect in cancer. That's the meaning of this. I do not know much about it, but anyway, thanks for your patient listening.